Retrieval-Augmented Generation, or RAG, shifts an AI from a generator into a researcher. The entire system operates on a single procedural instruction. Look it up first, then answer. The easiest way to understand this is to look at a hotel concierge desk. You have the guest, which is the user. The front desk where they stand is your chat UI. The concierge doing the actual running around is your application layer. The hotel's filing cabinet of policies is the vector database. The standard request form the concierge carries is your prompt template. And sitting in the back office writing the final response is the manager, which is the large language model. Notice who is actually doing the work here. The application layer, the concierge, is the active entity. It runs to the filing cabinet, retrieves the information, fills out the form, and hands it to the manager. The manager and the filing cabinet never actually speak to each other. This setup keeps the expertise of the AI model separate from the company's data. The system relies on the application layer to act as an assistant, fetching the specific facts required for every answer. To understand this assistant, we separate the process into two timelines. First is build time. Developers write blank prompt templates offline, ingest company policies, chunk them into pieces, and load them into the vector database. Second is runtime, the live action. During runtime, a customer logs into the chat UI and asks, "What's the baggage allowance for economy?" The application layer converts this question into a mathematical embedding, sending a search query to the vector database. The database isolates specific chunks discussing baggage and returns only those pieces to the application layer. At this exact moment, the database has not answered the question. It has provided the specific source material required to formulate a response. The prompt template is a rigid document dictating rules, like answer only using the context below, followed by blank spaces. The application layer injects the retrieved baggage chunks into the first blank and the user's question into the final blank. The prompt template exists as a fixed structure before the search happens. RAG is the mechanism that retrieves content to fill those specific pre-existing blanks. So, based on this physical sequence, what exactly does the large language model see when the application layer finally hands this form over? The LLM receives one single unified paragraph of text. It simply sees a set of instructions, a list of baggage facts, and a question. It has no idea that a template or database ever existed. Because the facts are printed right there on the page, the AI doesn't need to be trained on the airline's internal data. It just needs basic reading comprehension to summarize the text placed directly in front of it. The LLM reads the assembled document, generates a polite and accurate response based strictly on the provided baggage facts, and hands that text back to the application layer to display to the user. This modular design provides a massive business advantage. If the airline changes its baggage allowance from 7 kilograms to 10 kilograms tomorrow, you simply swap out that text in the database. The system instantly updates its answers. The AI requires zero retraining. To build this correctly, rely on 4 rules. First, developers write the prompt template once during build time. Second, the application layer is the sole conductor. Third, RAG fills the template blanks at runtime. Fourth, the LLM is completely isolated. Underneath the complex terminology, RAG is simply an orchestration layer. It glues verified search results to a user's question, ensuring the AI relies on hard facts rather than its own memory.